Yeah.
With 2 on the right, the numbers, is that like a table? Like, not a table, but
Yeah, I'm going to talk about that. It's the first time I've written it down like that today. It's a sequence.
So, sorry. Okay. So it's a pattern? So it's like, there's a pattern between all those?
Yeah,
in
because,
order, the
I
same
mean,
order, that
so
would be-
far we've been looking at different ways to see patterns. We've seen some of them
Do
visually
you want
with
to take this
dots.
on that one practically?
Yeah, well, hold on. Let's just do them together, okay? I think these don't really have anything new in them except perhaps this. So, we've got a table here with a function in it. I don't think there's any real defined pattern here. I just kind of picked those numbers real randomly, unlike all the other problems you have, which will have a real specific pattern that's not too hard to figure out, I don't think. So this one, who knows what the pattern is? I kind of picked stuff randomly. That doesn't matter. You can work with random stuff as well. So it says if the function is 6, in other words, if y is 6, what is n? If f of n is 6, what is n? So you look in the table, and what do you guys get for
I
n?
got 2.
2?
That's what I got. 2.
You look right here, right? That's where f of n is 6, and at that spot, n is 2.
Oh.
And then f of n.
So f of n minus 2, remember, don't say that as times. I want you guys all to say it right now with me. Can you do it? F of n minus 2. Good. So you're saying it's 0, Jeremy?
I say it's 23.
Yes.
Okay, here are a couple 23s is 0. F of n minus 2, remember, is 2 backwards or 2 forwards from where we are?
2 backwards.
2 backwards. So we were right here, right? So 2 backwards is there. Now they could have asked us for n there, or n minus 2, bless you, which would be 0. But they didn't ask for that. They asked for f of n minus 2.
Okay,
when
so
you put 0 in, what comes out? 23 comes out. You were giving me what goes in. But good, okay? So f of n equals negative 7. What's that one going to be?
2.
Right here is that. That is at 2, or negative 2 that happens, I should say. So if they want you to step forward 6 spaces in the function or the sequence, you would say that was
Negative 107.
negative 107. So from
I
here,
got that one right.
1, 2, 3, 4, 5, 6. If I put n plus 6 in, I get negative 107 out. Okay, so I gave you guys that yesterday as a little challenge, see if you can figure it out, because we were talking about sequences where we went forward a couple steps and backward, you know, that was the idea, so I didn't exactly write it like that though. So Kalena was just asking me a second ago, we've been working with patterns, basic patterns so far. Today you're just going to work a little bit more with a couple of those basic patterns, but they don't have to come as a sequence. I mean, they don't have to come as a table, they can come as a sequence of numbers. And of course it can come as a picture like the dots we've been doing as well. So this is just a rote sequence. This is what you're going to see more in higher level math classes, is a list of numbers like that. That's called a sequence when you have a list of numbers like that. So you can write that down recursively and explicitly. I think we kind of did that yesterday, so you guys should probably be able to do this. I'm going to talk about it with a little bit more vocabulary today though. Both of these sequences do the same kind of thing. In this unit, we've got 2 kinds of sequences we're investigating. What are called geometric sequences. Those are the multiply or divide ones. Is this geometric, either one of these?
No.
They're not multiplying or dividing. What's happening? Like, for instance, what's happening in this sequence right here?
Subtracting 6.
Subtracting 6? 6? Yeah?
I think I got it.
So adding or subtracting is what you call arithmetic.
I
Oh,
put
that
that
is a-
before.
Yeah, arithmetic. Go like old school on it, like, you know, Joseph of Arimathea. It's called an arithmetic sequence. Also, I think it comes to be a really simple graph. Anytime you have an arithmetic sequence and you try to graph it, which we're going to do just a bit of today, it's a real simple graph, okay? So, D, this thing is called the common difference. You guys already told me the common difference. What was it?
Negative
Negative
6.
6.
Negative 6, perfect. So, recursive. How did we write that down yesterday? There's nicer, more technical ways to write it, but you're up first. Okay.
Now equals previous term minus 6.
Nice.
I put last term minus 6 equals next term.
Yeah. You guys want me to show you the more technical way to write that so you already know a little bit? How about I show you?
Yeah.
Using this same kind of idea from right here. So if we could say a sub n, or the nth term, or the right now term, that's how you say that, is, how would you write the previous term? Think back to right there.
F of
A sub before is n minus 1. Minus 6. So those things say the same things, this just has the technical symbols in it, and that's what you're going to see as we go forward more, okay? This is the right now thing, this is the thing right before it. It's exactly what this says, don't make it harder than it is. Okay, you guys were doing better with the explicit yesterday too, I thought. Pretty good, equally good I should say. So explicit, we're going to say y equals, because we want an equation, right? An equation's got to have an equals in it.
x minus 6. No, 6 minus x.
No, it'd be x minus 6.
So we're subtracting 6 one time, or 2 times, or 3 times, or 4 times, so where's the x go? It goes on the negative 6, because you're subtracting it once, or twice, or 3 times. This could be 1, or 2, or 3, that's what a variable does. So the only question is, what other thing do I have to put in there to get it right?
Divide.
So let's think. Let's try it, okay? If we put 1 in right now, what do we get?
Negative 6.
Negative 6. But we're supposed to get,
17.
so we got to add something, right? To get from negative 6 to 17, how much do you have to add? You could use your calculator if you need to. 20 something, right?
Yeah,
Well?
probably like 22.
Let's try 22. Let's just try it, okay? So,
I literally want to say
let's plug in 1 again and see if it works now. So if I plug in 1, then I get negative 6. I'll even show my work over here. I'm going to get negative 6 times 1 plus 22. That's 22 minus 6, right guys? So that's going to be what?
17.
Isn't that 16?
Oh,
So you're really close?
23.
23, there you
I was
go.
gonna be my second guess.
So, do you guys understand what's important about this? Is that you guess and then you check. You don't just guess. You don't just check. You guess and then you check.
How do you check without guessing?
So, are we sure that's going to work? How about we plug in 2 and see if we get 11? If I plug in 2, I get negative 12, right? What's 23 minus 12?
11.
If I plug in 3, I get negative 18. What's 23 minus 18?
5. I told you, I
So
called it.
that's the right answer. So you guys had a little bit of trouble getting this 23 this time. I'm going to give you a second. If you're watching the video, I'd recommend you pause it and try to get it for this sequence. Let's get the pattern though. That part's easy, right? What's the common difference on this one? If there is one.
Adding up 11.
11. You guys agree with 11? Look at it.
Would it just be 11?
Plus
or
11,
Plus 11.
Yeah.
plus 11, plus 11. Yeah, it's plus 11 everywhere. That's right.
Just write 11, or would you write plus 11 or just 11?
You can write plus 11. I mean, that's cool. It doesn't matter. Good question, Jeremy. How about recursive? You guys thought that was pretty easy. What's that going to be?
No. Equals previous.
Hunter, you said.
Plus 11. Plus 11.
Good. If we wrote that the technical way, which you don't have to on this first couple if you don't want to.
No, it'd be A n.
Even if you put y equals, that's still pretty good, man.
Yeah, well, no, I put A n minus 1.
A sub n minus 1
A sub n.
is in subscript.
7 minus
Plus
1
11.
plus 11.
There we go.
That's so easy.
Okay, that part's real easy. This part's really more important, though. You guys were talking about how it's more important yesterday, I think, if you remember. So we're going to go
Wait, is that first part always the same? A n
X
minus 1?
plus 11. No. Yes.
most of the time until we get to tougher ones.
What are you
That's
talking
true.
about? It's X plus 11 and 11.
11x.
X. No.
Oh!
Oh, yeah.
Because
Plus-
we're changing by 1 11 if we go from there to there, 2 11s to go from there to there, 3 11s to go from there to there. That's what's variable, right? We've just got to say what our starting point is, and that's a little bit tricky to come up with sometimes. Is there an easier way to do this? Yeah. But I'm not going to show you the formulaic way until you have good number sense. Does that make sense? That's the way you actually learn how to do math. So I'll be showing you a more step-by-step approach at some point. But not yet. So 11x plus what? Because I think we got to add something because we're starting at negative 16. If I put 1 in right now, I'll get 11. So how did I get from 11 to negative
You
16?
would subtract.
Ah, this time I'm going to have to subtract something, right?
You subtract 11 to negative 16.
Maybe we should just go minus 16. Let's try it. We're guessing, right? You plug in 1 now, then you get 11. What's 11 minus 16?
This is 5.
Negative 5. Well, that's good, but we need to be back even more.
So negative 20. Yeah, 20.
It'd be another 11 that we need to go back, isn't it?
So then couldn't you just add 16 and 11? Yeah.
There it is. Do you want to check it now?
Yes.
Check it. Let me get a blue going on here. Let's check. 1, 2, 3, 4, 5. The fifth term when x is 5 is supposed to be 28. Let's see if that happens. So if I check here, I'm going to get rid of my recursive one. I'm going to say then y equals 11 times 5 minus 27. That's 55, isn't it?
Yes.
55 minus 27. I hate 5 and 7. Can you guys help me with the calculator there or something? It's 55 minus 27.
28.
28.
Oh.
Yay. What we made works. This thing is nice, remember, if you're just counting. Like if I ask you for, last thing I'm going to do with you guys today is, what if I asked you on this sequence for a sub 6? 1, 2, 3, 4, 5, 6. Then you just say add 11, right? You'd be using the recursive guy.
That's the wrong number.
But if I ask you for a sub 112, that doesn't really get the job done
So
anymore.
then you're gonna have
That's
to
where you need this
times
one.
No, 112 minus 27.
So why don't you guys tell me, what's the 112th term in this one? Help me out. You guys should be typing this in. Distractions.
I would type 1,205.
Confirm.
1,205.
1,205.
But you didn't do the
1,205. I don't.
I think she did it all in one shot. Okay. Right? Okay. So there you go. There's some more basic work with recursive and explicit arithmetic sequences.